Okay, this is day 2 for section 1-2, so that's on iterates, so we're finishing up our composition section. Basically, the idea of iteration has to do with using one function and instead of two, and composing it with itself. So you're just continue to use the same rule over and over again. So instead of having a function f and g, there's just a function f. So we use that same rule. It's called iteration. Every output then, every answer you get when you do that is called an iterate. So that's the word that you'll see for that. So we use the same function over and over again. So where do we start? Well, you start with something called an initial value or an x with the little subscript 0. So that can bother people, but the rule there is, or what we're thinking is just where are you in your list of numbers. So if you see an x with a little 0 next to it, that means your initial value or your first input that you're going to put in, your starting value. So when you see x0, just think of it, that's my first x, that's my first domain. At time 0, think of like if you're going to start a race, clock hasn't started yet, first number that I'm going to put in. All right, and how does iteration work? Well, then you put in that first number. So if there's your little x0, we do function notation. You put in the value, you do the rule, and out pops your first answer, your first output. Now it's interesting that they're using x here, but that's because of how iteration works. Your first output, the first iterate, we would call that x1, becomes the input for the next one. So that's that process of iteration. You're using the same function, same rule, f, but you're taking the output for one, it becomes the input for the next one. And you drew the rule, and sure enough, out pops your second output. That would be the second iterate, and we use that then as the input for the next one, and so on. It continues infinitely many times. So the idea of iteration is the output for one becomes the input for the next one. So the range becomes the domain for the next one. So let's take a look at an example of that so you can see what that looks like. So we have a linear function here, f of x equals 3x plus 2. It's saying that our starting value, our initial value, x0, they want us to start with 4. So I'm going to plug in a 4 first and do my arithmetic, and I get 14. What does that mean? Well, that means my first iterate, my x1, would be 14. Then it's my first output. So that output becomes the input for the next one. So I'm going to substitute in 14, get 44. So the second iterate, or the second output, would be 44. So the output for that one becomes the input for the next one. So I put in 44. And I think that's 134. So my output is 134, my third iterate, and then that would become the input for the next one, and so on. So for the first starting value, that gives me that initial, and from every point after that, whatever I get from my output, it becomes the input for the next one. So we'll just try that one more time, another linear, and a starting value of 1. So x0 means, okay, yep, that's the number I want to start with, so I'm going to substitute in a 1 first. And that will give me a -1. So my first output is -1, which comes the input for the next one for my second iterate, which should be -5. So x2, or the second iteration, is -5. And then that becomes the input for the third one. So I get -13. So my third iterate would be -13. So this composition with one rule, composition with itself, called iteration.